Hello and welcome to the fourth episode of the Data Science Daily series. And I'm very excited to have you here. Today, we are going to discuss a very interesting application of artificial intelligence. We already understood in the last session what is artificial intelligence. We looked at the different types of artificial intelligence. And we also discussed two use cases of artificial intelligence. The first one being self-driving cars, which were related to computer vision. And the second being Alexa, which is related to more of language and speech. So just to give a hint, we will talk more on the language side today. So without further ado, let me share my screen and let's get started. Okay. All right. So you must have heard about this buzz of ChatGPT, and you might have already used this application as well. So let's see a very interesting question that I had asked ChatGPT a while back and what it responded. Now, before we get into that, ChatGPT is what is called as generative AI, right? Because it is able to generate a lot of text, a lot of analysis as well, right? So we'll understand what is generative AI more in depth later on, but let's understand first, right? How good exactly is ChatGPT? So the question I asked is explain quantum theory to a child, right? This advanced physics concept in the form of Snoop Dogg. And what it responded is, all right, little homie, let me break it down for you in Snoop Dogg style. Quantum theory is like a whole new level of coolness in the world of science, just like how I bring the funk in the world of music. You know, everything around us is made of teeny tiny particles called atoms, and so on and so forth. And you will see that, there are three lines in each stanza, and it has really written out that song in the form of Snoop Dogg. Now, it is so powerful, right? Just a few words of instructions, and it is able to give you that interesting output which makes sense, which makes meaning, right? How is it actually doing that? How is it understanding language? It is understanding language because language can be represented as numbers beneath the hood, and it is basically learning from a lot of data. So, more formally, right, ChatGPT is generative AI, but within AI, there is a field called natural language processing, with which ChatGPT uses. And this is what we are going to dive into today. What do we mean by natural language processing? What do we firstly mean by natural language, right? So languages that humans use to communicate are called natural languages by computers, because the reason being we also have computer languages, right? Like programming languages like Python, Java, right? JavaScript, and so on. The reason we call it natural language also is computers cannot understand our human languages directly, right? So we have to make the distinction that these are natural languages and these are programming languages. And the field dealing with processing and understanding language as humans speak and understand it is called natural language processing, right? This is the big subset of field dealing with language. It can be text, right? It can be speech, and so on. It is a field of artificial intelligence, and it is rooted in the theory of linguistics. Even before artificial intelligence actually became a thing, natural language processing has been there for about a long time, right? And there was a lot of linguistic and research which went on, like computational linguistics was already there before we had this new paradigm of artificial intelligence where we are giving a lot of data and it's able to learn and churn that data out, right? Why do we actually care about processing language at all, right? The volume of data that is unstructured is about 80%. And when I say unstructured, that means it is text based or it's image based. It's basically anything but tabular based, like Excel or CSV files based, right? So 80% of the data available out there in the form of, if you look at the World Wide Web, if you look at, other kinds of sources like research papers, news articles, all of that is text data and it's unstructured. It cannot be directly stored in databases. And you need a different kind of an analysis that you want to do for such unstructured data. Now, we discussed this, that AI is the overarching field, right? Where the intelligence is about mimicking what humans are doing. It's very similar to how humans are seeing. We have computer vision, how humans are speaking and understanding language. We have natural language processing and so on. So it's a large field. Within that, we have machine learning as a field that we introduced. And within machine learning, we have deep learning. And natural language processing is a subfield of artificial intelligence, and it has a bit of overlap with machine learning and deep learning as well. So this is where NLP sits, and it's a subfield of artificial intelligence. Now, if you try to understand what are the two different fields within natural language processing, right? What are the subfields of NLP? As humans interact with language, first they understand language and then they are able to generate language. As a baby, you are not able to speak. The reason being, you're not able to understand as well. Once you start understanding language, you're also able to speak it. So the first field is called, formally, it's called natural language understanding, which deals with understanding the semantic relationships between the text that is given as an input to the algorithms. What is the semantic relationships? Meaning, right, what is the meaning of that text? It's trying to understand that. And this is very helpful in use cases like sentiment analysis. If I give you a lot of tweet based data and you want to tag whether this is a positive sentiment or a negative sentiment, NLU is very, very helpful. Like we saw in the previous slide, we talked about ChatGPT. That is the field of natural language generation. It has understood the text, it has understood language as we know it, and it is able to generate natural language as well. So there are two main subfields. One is natural language understanding, and the second one is called natural language generation. Let's look at some interesting examples now, which will make your head go round, and you will see why language is such a difficult kind of a data to master by any algorithm, and why this is such a big field of research right now, and why so many companies like Google, Meta are all trying to crack it, right? Like OpenAI, Anthropic, they're all launching their own models. Similar to ChatGPT, you have a Google model called Gemini, which is very, very powerful. Anthropic has recently launched its Claude 3 models, which are supposed to be better at benchmarks than even the recent state of the art models. And a lot of companies are launching their own, like Meta launched the Llama 2 models, right? Which were supposed to be the best open source models out there. Open source meaning you can directly download the models on your local system. You don't have to pay any fees as such. So all of these models which are getting launched are being launched to understand language and to be able to generate good amount of syntactically correct language. Now, why is language such a difficult kind of a data to master? Let's take this example. Listening to loud music slowly gives me a headache. Listening to loud music slowly gives me a headache. This is the first one. And the second one is listening to loud music slowly gives me a headache. There are two different ways in which you can interpret it. Was the person listening to music slowly, right? Or is it that the headache is developing slowly? So is it that listening to loud music slowly, if you listen to it slowly, that gives you a headache? Or is it that if you're listening to loud music, that is slowly giving the headache, right? The headache is developing slowly. So this is very ambiguous, right? This is one example. Let's look at another one. The complex houses married and single soldiers and their families. Are the houses complex, right? In this statement, the complex houses, what does that exactly mean? Now, the complex is referring to the building apartment. And houses is actually a verb in this sentence. It's not a noun as we usually know it. So, houses is like shelters, married and single soldiers. So what natural language processing does, it solves this particular kind of ambiguity using something called as part of speech tagging. What part of the speech is it? Is it a verb? Is it a noun? And so on. This is one specific example of a task that NLP does. Let's look at another one. John had a card for Helga, but couldn't deliver it because he was in her way. Now, think about it. Was Helga in John's way? Or was John in Helga's way? he was in her way. Now, as humans, we know that he refers to John and Helga probably is a woman, so her refers to Helga. But still, for a computer to understand this, and even for most humans to understand this, it's not very clear who was in whose way. Now, what NLP does is it solves this kind of an ambiguity using co-reference resolution. It identifies all the references in the text that refer to the person John, and it finds all the references in the text that refer to the person Helga. And it does, wherever there is ambiguity, it does kind of a co-reference resolution. This is the second kind of example of an NLP task that we just discussed. The first one was part of speech tagging. The second one is co-reference resolution. And there are a lot of other examples. There can be metaphors like, for example, this: the Kiwis won the match. Is it the bird Kiwi? Who won the match? The Kiwis won which match? Were they fighting against birds? No, this is referring to New Zealanders, because this is how we refer to New Zealand team, as the Kiwis. So you can see that these are just a few examples, but language can be very, very complex, especially if you're giving large documents, even more so if you're giving technical documents like financial documents, science research-based documents, and so on. Now, understanding language, this is another example. Literally, your Facebook message app is useless. You only want it to increase profit. Please fix yourself. It's sad at the rate Facebook, right? Sorry, Facebook, but this is just an example tweet that I have used. Now, there are different angles of this language that we can infer. The emotion is frustrated. The emotion can be inferred. The tone is negative. That can be inferred. The organization that is being talked about is Facebook. The product that is being talked about, right? It's the message app, so it's the messenger app. That can be inferred. The adjectives that have been used, which are the negative ones, is useless and sad. And the language can also be classified as it is English and it is informal, because your is not written as Y-O-U-R, it's written as U-R, so it's informal. All right, now let's look at a few examples of NLP applications and where all does natural language processing actually help us. And by extension, how would these new models such as ChatGPT actually help us? First one is machine translation. There are around 7,000 languages in the world. Did you know that? A lot of them are not modeled currently, which are not modeled in terms of they cannot be translated from one language to another. Think about Google Translate. Google Translate uses natural language processing beneath the hood to do machine translation. Now, when we are talking about machine translation, we are not saying language translation, we are saying machine translation, right? Where we are putting an emphasis that the translation is being done by a machine, in this case, an algorithm, right? So that's why it's called machine translation, because the translation is not done by any language expert, it's done by a machine or a computer. That's why this specific application is called machine translation. And Google Translate basically is an application of machine translation. The second example is question answering and information retrieval. Ever used a chatbot? Like, ever put something to Google and asked it to return an answer to you? Yeah, have you seen what happens? It refers certain websites and it puts them on the top, and it says that this particular answer, it gives a default answer, and then it gives you that this is the link for that default answer that's coming up, for the most relevant answer that's coming up. So it is doing question answering, and it is also retrieving the relevant websites, the links of those websites. So it is even more with chatbots like Gemini or ChatGPT. They are able to even do this much better than Google is, because Google is a search engine primarily, right? Google search is a search engine, whereas Google's Gemini is a chatbot. And if you have not used Gemini, definitely try it out. It's a wonderful tool. Okay, let's go and look at another use case, which is summarization and analysis of text. What are people talking about and why are they talking about it? Now, this is very useful for reporting purposes. When you look at news articles, if you look at a large news article, what Google does and what a lot of websites do is they generate automated news summaries. so that viewers can simply look at the summary and understand the context of that news article before diving into it further. So it is used to condense articles and highlight key points. This is another very, very useful application of natural language processing. Moving on to speech, automatic transcription of audio and video to text representations. Now, if you're watching this video, if you click on view subtitles, the CC button that you have in bottom of this YouTube video, you would be able to get the captions and the transcription, and that is automatic. Now, how is that getting happened? That is happening because speech is getting translated or transformed to text, and YouTube's backend machine or backend algorithm is actually understanding that text and generating captions, right? It's basically understanding speech to text, right? And then it's basically just putting that out actually. So it's understanding speech first. And this is again an application of natural language processing. You can also dictate a text message on your phone and it will do the reverse. Right? It will actually do speech to text only. So it will transcribe your speech to text and you can basically send that message as well. So it's such a nice feature to have. Looking at sentiment analysis, that's another feature. It's very useful in customer support, engineering, and marketing departments. If you look at social media has a lot of sentiment analysis which is going beneath the hood, and it basically flags harmful or offensive content, right? That's almost similar application like sentiment analysis, like tagging different kind of content based on what the language is, what the content is, and so on. Text classification, providing reference to answers and answering in an interactive manner. Think about when you're trying to search an email in your email, right? Search a particular email that came to you, let's say 10 days back, and you type the title of that email. What the mail service does, it retrieves that particular email back. How does it do it? It classifies that what you have asked for is very similar to that particular email, or it probably does a keyword search as well. And it classifies and gives that back to you. Spam versus not spam. Spam emails go to the spam folder, not spam are in the regular folder. This is text classification. Now, the reverse of speech to text is text to speech. Voice assistants like audiobooks, they read the text that is out there and they give that sound so that you can hear it and understand the story or the text that is there. So these are all applications, and there are many, many more applications of natural language processing. It's a huge field, and it's very, very exciting field because there is a lot of development which is going around with these new large language models that are coming in, like ChatGPT, Gemini, Claude 3, and I'm personally very, very excited to see how the future is. This particular session was to give you an understanding of natural language processing and make you familiar with this terminology and this field, because it's going to be very, very, very important in the coming days. And it's one of the most high value fields within AI. Firstly, because there is so much data. Secondly, because there are so many applications, text is used everywhere. And thirdly, because it's difficult to mine. It's not like structured data where you can store it in a database and just mine it. You need to be able to clean it. You need to be able to do advanced things. There are nuances to language and so on. So I'm personally very excited. You also keep watching out for new developments and stay tuned. This is all for today. As always, if you have any questions, please feel free to put it in the chat, and I will answer them as quickly as possible. Thank you for watching. See you tomorrow.